Hello friends, I am Rakesh Kumar. The topic that I am going to discuss today is scattering matrix. As per the network theory, low frequency circuit can be described by two-port network and their parameters such as Y parameter, Z parameter, H parameter and ABCD parameter. Now if the frequency are in the microwave range, the Y parameter, Z parameter and H parameter are readily available to measure the total voltage and total current on the port of the network. Secondly, some of them often circuits are difficult to achieve on a very broad band of frequencies. And at last, active devices such as power transistor and Hammond diode frequency will not have stability for a sort of open circuit. Therefore, we have designed a scattering matrix which relates the voltage wave incident on the port to that reflected from the port. The scattering parameter can be measured directly with a vector network analyzer. Now, suppose if we have configured a N-port network which is shown in the figure where Vn plus is the amplitude of the voltage wave incident on the port N and while Vn minus is the amplitude of the voltage wave reflected from the port N. Then the F matrix can be defined in relation to the incident and reflected wave as V minus equal to matrix of S multiplied into the V plus. Before giving the relation, first we will see the diagram of the input network. Therefore, we have considered an N-port microwave network which has got N-port here at first port V1 minus and I1 minus is the reflected voltage wave and the reflected current from the port number 1, while V1 plus and I1 plus is the incident voltage and the incident current at port 1. Similarly, at the port N, we can see that the incident voltage at port N is Vn plus, while the incident current is In plus, while the reflected voltage at this terminal is Vn minus and the In minus. Therefore, for calculating the scattering matrix, Sij can be given as Vi minus divided upon Vj plus if if Vk plus equal to 0, Vj not equal to J. Therefore, Sij can be found out by driving port J with an incident wave of voltage Vj plus and measuring the reflected wave amplitude Vi minus coming out of port I. The incident wave on the port except the jth port are set to 0, which means that all the ports will be terminated in mass load to avoid the reflection. Now, suppose we have considered a two-port network where A1 and A2 are the incident wave at the port 1 and port 2 respectively. In the two-port network, V1 and V2 are the reflected wave from the port number 1 and port number 2 respectively. For these two-port network, ratio between the V1 and A1 and A2 can be written as V1 equal to S11 into A1 S12 into A2, while V2 can be given as S21 into A1 plus S22 into A2. Now, at last, we will discuss the properties of S matrix, which states that the S matrix is always a square matrix of the order n cross m. While the second property states that S matrix is a symmetric matrix. It means that Sij will be equal to that of Sji. The third one property states that S matrix is a metric matrix. It means S matrix multiplied with the conjugate will give the unit matrix. And at last, the last property states that the diagonal elements of S matrix will give the reflection coefficient of the respective port.